Hello, everyone. Good afternoon to you. My name is Ravi Subramanyan. I work for HiveMQ. I'm the industry solutions manager for some of our verticals like manufacturing, transportation and logistics, and energy. Today, I'm going to take you through some of the edge to cloud architectures that we encounter within HiveMQ and how that integrates to Gravitee. So let's start the presentation. So let's kind of look at the real opportunities around some of the industry verticals we see, specifically around manufacturing, right? So the use cases of manufacturing are in supply chain, where we get to work to overcome the disruptions caused because of like the lack of data, the lack of the global data that is created by COVID and other reasons. So with HiveMQ and edge to cloud solutions, you can overcome these disruptions in operation to help with operational improvement, throughput to meet global demands, OEE, which in other words is overall equipment efficiency, and how you can help improve that using edge to cloud solutions, and not last but not least, analytics, right? That can help reduce downtime, that can help increase forecast prediction and things like that. So this is kind of like a typical edge to cloud architecture that we see, where you have on the left, you have edge devices, right? You have the robots, you have mobile devices, you have other kinds of devices that are generating data, that are sensorized, and then all that data comes into some kind of like an edge gateway or a server that has the capacity to process some data. And you want to do some analytics on the edge because not all data needs to go to the cloud. Some of them can stay on the edge because the use case may demand for you to be able to react immediately as opposed to the data getting to the cloud. And also the cloud is typically, or the enterprise is used for more longer term analytics as opposed to the short term analytics or quick response that's needed on the edge, right? Then the data is sent over cellular or other methods to like an edge network, which is typically in the data center. From there, it can go to the enterprise. It could be a complete cloud or it could be a hybrid solution where things can happen, right? Some of the processing can happen. So what are some of the technical challenges, right? What we clearly see there is integrating the data from your edge to cloud, which in other words is OT to IT, getting some of the real-time data insights, and being able to connect all these like global enterprises, so global factories, manufacturing plants, and things like that. Let's look at each one of them, right? First is like integrating data from OT to IT. This is a big challenge because of the varied data sources or protocols that we encounter in the space, lack of a unified ecosystem, a lot of legacy systems which prevent you from being able to talk to other systems, and truly like prohibits like the convergence of OT, which is operations technology, to IT. Then the second one is like insights from real-time data. Now, a lot of systems claim to be able to provide real-time data, but it's not really. It's not quite real time. Right? When you're trying to do some analytics based on data where you are depending on the data to be real time, that's where you have a problem. You're trying to build, say, digital twins, for example, right? The twin is only as good as the data that is fed to it. And if the data is not real time, then the twin is not quite as effective, right? And you're also dealing with sheer lot of volume of data. And again, not all data needs to go to the edge or the cloud or the enterprise. A lot of it can actually stay in the edge. There is a lot of data complexity, as mentioned before. And then this, like last but not least, the lack of reliable way to move this data, if you will, that is effective. The third one is a global view of the data, right? Because of the fact that you have like siloed production lines and sites, manufacturers actually struggle to add new use cases, to be able to get a global view of all of the data across the enterprise so that they can make some continuous improvements at scale. Right? Every factory is like a snowflake, and there is interoperability issues, and then operational overheads is always there as well. So let's look at MQTT and why it's one of the de facto standard protocols for movement of data within industrial IoT, right? Because it's lightweight and efficient, because it's a publish subscribe based protocol where you have a centralized broker and you have clients that are publishing and clients that are subscribing. So the publishing clients can publish data when it is available, right? When the data is available, as well as when the network connectivity is available to the centralized broker. And then it does that on like a particular topic name structure. And then the subscribing clients can be notified about that data availability and can get the data. So it's all is synchronous. So it's very low bandwidth. It has reliability built into it. It has what we call quality of service built into it. And that can be depending on the needs, right? You can be quality of service 0, 1, or 2, depending on the needs. And also it has like security as built into it as well with TLS and SSL integration. Again, because of the fact that it's exception-based, it's very lightweight. The packet size is very light, and it's very flexible, and you can have user-defined properties as well. So these are the reasons why MQTT has really become popular, and it's one of the de facto standards when it comes to data movement. Now, there is another thing called Sparkplug, specifically in manufacturing, because MQTT doesn't really clearly define like the topic name structure, or more of like where the data is coming from, the context behind the data, which is absolutely important in the world of manufacturing. Sparkplug actually is a data framework on top of MQTT that is defining these things. So the combination of MQTT and Sparkplug is absolutely essential or crucial for manufacturing, because it offers you that additional interoperability and standardization. It contextualizes the metadata, and then it also provides the topic organization. It provides organization of message types and payloads. So that's the reason why Sparkplug is also getting a lot of popularity. And the other thing is that whole unified namespace concept. So with the combination of MQTT and Sparkplug and the publish subscribe architecture, you can have a unified namespace where all your data coming from different devices, different systems, maybe machines, ERP systems, SCADA systems, MES systems, can all be organized in a common way with what we call a unified namespace from an organizational perspective, divisional perspective, subdivisional perspective, and then going down to the actual data, so that you can have an easy way to gain access to the data. You have a clear definition of the data, and then that data can be used for whatever processing is needed based on that. So this is kind of like a way to organize a unified namespace architecture, right? Where you have devices that don't understand MQTT Sparkplug, that are talking to the intermediary gateways or PLCs. And then through that, the data comes into a broker, and then the data can then be shared with other systems that needs that data. And then notice that the arrow is bidirectional, right? Which means your enterprise systems can also share it with the edge systems and vice versa. So it promotes bidirectional data communication, all brokered through a centralized unified namespace supporting broker at the center. Now let's see how HiveMQ does that, right? So HiveMQ is that unified namespace broker. And one of the reasons why HiveMQ is a pretty popular broker is because of the enterprise nature of the HiveMQ broker. Now, what does that mean, right? That means that we can support scalability. We have benchmarked 100 million connections, concurrent connections at the same time. That's the level of scalability we can go. We provide high reliability. We provide high availability, which means that if for whatever reason any of your nodes go down, you have the replication of the data across multiple nodes, so that the second node can automatically take over. So and the failover happens very seamlessly, so that from a customer perspective, there is no perceivable loss of data or loss of operations, which is absolutely crucial in manufacturing environments. And the other thing is the extension frameworks that we have, which basically uses our SDK and extends that MQTT data or IIoT data to streaming services like Kafka, Kinesis, PubSub, Google PubSub, or AWS Azure, or to databases like MongoDB, Postgres, SQL, MySQL, and through other services through custom application. And recently we have Snowflake as well that we can support. So that is kind of like, so taking data from different devices and being able to seamlessly share it with other devices. Now, in this quest, we also have a couple of other things that we added. One is Edge, right? Because we have to talk about Edge, because a lot of the processing can really happen at the edge, so that like you can streamline the data on the enterprise or the cloud. So with that in mind, we have launched our HiveMQ Edge as an open source software. And so this HiveMQ Edge is capable of supporting a few commonly used protocols out there, like OPCUA, Modbus, Siemens S7. So it can talk to the devices over these protocols, interpret the data, bring that into like that MQTT Sparkplug format. And then we also have another functionality called Data Hub, which deals with the data quality. Because at the end of the day, the data is garbage in, garbage out. And you want to be able to correct or modify or improve the quality of the data at where the data is created at the source, as opposed to the data going to enterprise or the cloud, where it is going to be very costly to make those changes. So Data Hub has, you can apply policies through which you can modify or correct the data, if you will. So a combination of our edge solution with our broker and the Data Hub is that true sensor to cloud experience that we can offer to our customers. And that's why customers really love our solution, because of what we can do when they start. And also we can support their roadmap as their requirements grow over time. The next few slides basically talks about some of these features that I already touched upon, which is basically reliability, which deals with zero message loss, no single point of failure, zero downtime upgrades, reliable communication, which some of it comes through the implementation of MQTT standard, a protocol, and other things are like what we have done on top of that. And scalability, we talked about the 200 million benchmark, elasticity of the scaling without through the load balancing that we talked about, the linear scalability as well. That's key to our solution. The interoperability, again, we talked about like where HiveMQ can run anywhere. It can run on premise or on the cloud, public or private. It can support all these extensions, as we called. We talked about it can connect from anywhere using our edge solution or through clients, which are offered in all these different versions. And again, we talked about like talking to databases or enterprise security, which is absolutely important. And edge, again, we talked about like some of the edge support and why we do that, because we want to truly offer that sensor to cloud experience, and we want customers to be able to do things at the edge before they can venture into the enterprise or to the cloud. Our Data Hub, again, improving data quality through policies, through validations and transformations, through schemas, policy actions. And it's all done through our control center, which is basically our tool to observe things as the data flows through to the system, right? That's another thing that we offer to our customers. And finally, we can talk about how it all comes together, right? And this is kind of important. I want to spend some time to talk about this. This is kind of like the culmination of all of the things that we do, and why we're here, right? One of the things that we do is we also interface with Gravitee. Gravitee has this API management gateway, which is natively able to talk MQTT, and that is an integration that Gravitee has done. So where the use cases for HiveMQ and Gravitee comes together is HiveMQ does the IIoT part of things, right? So talking to machines, talking to applications, talking to other systems on the OT side of things, and combining that with IT data like MES, Historian, and ERP, and things like that. That's kind of like where HiveMQ really comes in. Where Gravitee really scores is more kind of like into the things like HTTP post, for example, or HTTP GET, which are kind of like mobile-centric application protocols or schemas, if you will, right? Or WebSockets, for example, for event portals or dashboards, SSE, and webhooks. And these are the things that Gravitee really, the API management gateway that Gravitee has really focuses on, right? And this is kind of like when we marry the power of HiveMQ with what Gravitee can do from a IT perspective, that's where the magic really happens, right? And this is where we did a webinar a few months ago with Gravitee, where we actually did a demo of this. If you haven't already seen that, I would encourage you to go back and look at the webinar where we had that wonderful demo that was given, and that kind of like explains things in a lot more detail, where how the Gravity's API management system comes together with HiveMQ to provide additional value. So maybe we can look at each of the use cases in more detail and how the solutions come together and help out, right? The first is the data ingestion use case. So HiveMQ kind of like manages the data ingestion from IoT systems, right? Industrial IoT systems. And that data is available again over MQTT. And that data is important, for example, when you're building mobile apps that need some of the IoT data, right? So one way that Gravitee adds value there is doing an HTTP post over MQTT for some of these mobile applications to get this IoT data, right? And that is absolutely important because more and more mobile applications are being used by enterprises for a variety of purposes. Like, for example, if you take a factory floor, right? So a lot of the manufacturing engineers, maintenance engineers, for example, carry their iPads or carry their mobile phones wherever they go. They want to get an experience where they want to see all of their key parameters of things that are happening, want to see the condition of their machines, and they want it to happen in a mobile way, right? So that they can validate things, they can see what is happening, and if they see any exceptions, they can handle that. They don't want to be stuck in front of their machine all the time because they are going between different machines. Maybe they are in a meeting, they are somewhere else, so they want to be able to monitor it, and it absolutely becomes important. And this is where I think a mobile app, which is built using obviously IT solutions that would need the data from MQTT, from the OT side of things, from IoT side of things, is absolutely important. And this data ingestion is absolutely important for that. And adding on to it, right? It's not just about data ingestion, but it's also about event consumption, right? Because we talked about getting those exceptions, right? These are events, right? So when some parameter is hit, like you're setting the pressure to be within a certain range, and somehow if the pressure value from that particular machine, for example, falls outside that range, that could be an event that is sent to the mobile app, so that the mobile app could then react and create an alert that goes to the supervisor or to the maintenance engineer, so they can take action on that. That is an absolutely important thing, and that's kind of like the event congestion. So there's data ingestion, which is HTTP post over MQTT for mobile app, and then event congestion is HTTP get over MQTT for mobile app. So these are two of the mobile app use cases. The third one is event consumption or WebSocket over MQTT for portals and dashboards, right? So this is another important way that you want to be able to consume data, to be able to create portals and dashboards, and that wants to consume data over MQTT. And again, this is where Gravity's API management will come together with HiveMQ to provide that use case of WebSocket over MQTT for event portals and dashboards to be able to consume data. The fourth one is, again, while we are talking about event consumption, SSE over MQTT for data analytics. So this is kind of like going into more detailed analytics that needs like some of this SSE data over MQTT. So that is that use case where HiveMQ and Gravitee can come together for that use case. Last but not least is webhook over with message filtering. So again, this is important because not all of the message needs to be sent, right? You want to be able to filter based on criteria. So webhook using message filtering over MQTT for some of the advanced data use cases becomes absolutely important in that scenario. And so these are some of the ways where Gravitee and HiveMQ can come together to solve real life problems, where on one side you have somebody that is really strong on the IoT kind of use cases and can make the data available. So talking to the using the edge solution to talk to the machines, to interpret the machine data, if you will, bring the data in real time, which is absolutely important. And also make sure that the quality of the data is maintained, because you want to ensure that only the right quality data comes through, because as I mentioned before, the cost of having the data escape into the enterprise or the cloud and fixing it there is much larger than the cost of fixing it right at the source of the data. And this is where I think the edge of network or the edge system is absolutely important, because you want to be able to do certain things, whatever things you can do, whatever processing you can do based on different use cases on the edge, especially say in the oil and gas case, where you want to be able to monitor certain parameters of oil pipelines. And then if it goes beyond those parameters, you want to be able to take action immediately, right? So this is where that edge comes together. And based on like the data flowing through, right, based on criteria, you can pass the other data or the summarized data, if you will, to the enterprise or to the cloud. And this is where I think cloud processing can happen. And again, that integration with the Gravitee comes together to take some of this data and integrate that with the some of the cloud solutions for mobile apps, for event portals, dashboards, for some of the advanced data analytics use cases. And that's how we kind of like the combined solution provides value. And again, I'm very happy to be at this event here to talk about some of these use cases. We are very excited about our partnership with Gravitee and what we can do together. And I would again like to remind you of the webinar that we did a few months ago with Gravitee. Alex and me did the webinar, and I would encourage you to go and check it out and see for yourself some of the things that we talked about and the demo that we did as a part of that webinar, which will be very useful for you. I would like to stop the presentation here and leave some time for questions, because I think you might be very excited about what we have to say and have some questions. And so I would like to take this opportunity to have you take any questions. And thank you again for the opportunity, and have a wonderful Gravitee Edge conference. And I will talk to you folks soon. Thank you. Bye-bye.